In this lesson, we're going to learn about the atomic emission spectrum, and then later the Bohr model. But first, let's talk about the atomic emission spectrum. And to kind of get us in the right framework, what exactly is the source of light? So you flip a switch, and then a light bulb goes on. What exactly is allowing that light bulb to then emit light for us to see? Where does it come from? So one thing that you should recognize is that really any substance, regardless of what it is, can actually technically emit light. Because ultimately, any substance can release energy. Remember that light is a form of energy, right? Light is actually little packets, little bundles of energy. So anything that can release energy technically can also release light. And where does this emitted energy come from? It again comes from some other absorbed energy. So when we flip on a switch, right? When we flip on a switch, that's actually allowing electricity to go through certain substances, which then allows it to absorb the energy and then eventually releases it. So what forms of energy can be absorbed by atoms, which then can eventually be released in the form of light? A couple of forms. One energy form that you'll probably see a lot of is heat. Putting in a lot of heat will cause something to emit light because the something will absorb heat energy and then release it as light. Also, as I mentioned earlier, electricity is a pretty good source as well. Right? You pump in electrons through something. Those objects will absorb the energy from that electron and then release energy in the form of light. Also, something else that can do it is other forms of light. Right? So if you shine light on certain things, they can then absorb that light energy, turn around, and then release energy in the form of some other kind of light. So as you can tell, it's all about absorbing energy and then releasing it. So what we get into here, some terminology, is to help us understand this idea. So first of all, just recognize that any atom can absorb and release energy. Right? That's kind of reiteration of what we said already. And we refer to the ground state as an atom that's in its lowest energy state, meaning it's kind of its baseline, it's sort of its regular day-to-day action, it's kind of hanging out. That's considered its ground state, where every electron or every part of the atom is in its lowest energy state. Whereas an excited state is, we're referring to an atom that it's absorbed some kind of energy, right? Absorbed some kind of electrical energy or heat energy or some form of other light, and it's absorbed that. So ground state, again, an atom can be changed into an excited state when it absorbs energy. And this kind of is where we start talking about energy levels, right? So you can kind of imagine, different levels of energy based on how much energy you absorb. And this energy level is actually something that's related to the quantum relationship between energy and the atom. So energy levels refers to the quantum states that an electron may possess. Now that right now it probably doesn't make a whole lot of sense, and we'll refer to that in just a minute. But let's go and take a look at sort of how we kind of arrive at this. First of all, when you take light and you can split it up, we saw this as a demonstration, you can see that it's made up of different colors, right? It's never really just one color a lot of times. It's actually multiple colors that combine to make that light. So you see right here in this first section, right, high density hot matter, so basically this is your white light, right? And this white light, of course, you can split up and see the continuous spectrum. But when it comes to a hot gas, the ones that we saw in class were like mercury, or you might see another one that's made of just helium, right? We saw those. You might also see ones made of hydrogen. So those substances, right, each of them independently in the gas tube will generate its own spectrum, right? And notice how, again, it'll be its own unique spectrum. So each light or each color will give off, each substance, each element here will give off its own unique spectrum. So white light, right, we see on the top here is continuous. The bottom one, the spectrum is not continuous, right? You see individual kind of specific lines of light. So if you kind of think about it, right, how exactly is this related to quanta? Well, remember, if it's not continuous, that means it has to be only very specific amounts of energy. So that's why you see in this bottom part, only very specific bands exist, or very specific lights exist. And that's consistent with this idea of quantization, right? That there's no in-between, right? You don't see any colors being emitted within these dark areas because, that's not allowed. And so this diagram kind of helps us sort of visualize this. You'll notice that you have, first of all, these diagrams. The left side's excitation, the right side's relaxation, and then these arrows effectively represent the energy going from low to high. Each of these right here, and I'm referring to both the one on the left and the right here, each of these represents the energy level, right? So this is one energy level, right? This is another energy level, and this is a third energy level, lever, right? And each of these energy levels, right, these represent some amount of energy that an electron can possess, and we're just going to say hydrogen. We'll see the significance later on. So I'm going to represent them by just using little e's here. So for example, this electron right here. And this process of excitation is going to require you to input energy, right? And so energy can go in, I'll just use this right here. Energy goes into this, right? Gets added into this electron. What exactly do we mean by energy? Of course, we mean things like light energy or heat or electricity, right? So these things, again, are added to this electron here. This electron absorbs that energy, and as a result gets moved up to some other energy level. Now, again, these are all hypotheticals, so this electron can move to this energy level. It could also very well move up to that energy level, too, if it absorbs enough energy. But remember, they actually can't just absorb so much energy to where it ends up just right here, or arbitrarily kind of shows up somewhere right here, because they're not allowed, right? Electrons are not allowed to just hang out on that energy. They have to be on these very specific levels that are present, right? So the energy, again, initially here, right, is hanging out here at the bottom. This is showing that it's in its ground state, right? It hasn't absorbed energy yet. But then when it absorbs energy, it has to absorb enough to where it can either land here or land there. Now, that's the initial excitation. Let's go and take a look at the right side here. So this is going to be what happens as it relaxes. So let's say we have an electron that's up here now. Actually, let's make it consistent. Let's say we have an electron that's right there, right? So what's going to happen is that this energy is going to be released, right? This is the process called relaxation. You can also refer to it as release. And so as it releases, right, it's going to drop from here to here, right? Again, it can't just drop to where it only ends up somewhere in this little in-between space. That's not possible, right? It has to have very specific amounts of energy released. And the amount of energy released allows the electron to return back down here to its ground state. Now, the interesting thing about this, though, is that this energy that's released, though, right, this amount of energy right here, it has to go somewhere, right? The energy came from something, and now, as it's being released, it also has to go somewhere. Well, it turns out that energy is going to come out in the form of light, right? So we kind of have this little squiggly light come out. That's the form of light that's released. So this is going to be called, or it's abbreviated h nu. Remember that h nu, right? That's those two things multiplied by each other equals energy, right? That's going to be how you calculate energy. And so that amount of energy that's released, that's h nu. And so, that corresponds to this energy that's being released as it goes from this energy level down to this energy level. Right? So that's, again, the process of relaxation. So whenever you see this light that comes out here, right, that corresponds to electrons that are going from one energy level down to a lower energy level. Well, again, let's hypothetically say that we had the second electron here, right? The other one that could have gone all the way up here, or that electron that could have gone up to that energy level, a little bit higher. Well, what can this do? Well, again, as you might imagine, it can relax down to this one, or it can relax all the way down here, right? Depending on just what it feels like doing at that time. And like we said, energy as released has to come out in some form. Well, it turns out when electrons relax, right, it releases energy in the form of light. So these, again, are going to have some other kind of colors. Let's go ahead and draw a little squiggly line going out this way, right? Notice how the wiggle, or the squiggle there, is a little bit different than the original blue one down there. And this is going to have its own energy, right? Because this amount of energy from here to here that's being released is different than the amount that was released from here to here. So you shouldn't expect the same energy to be released. And since there's different energies, that means they have different colors too, right? And then if the electron goes all the way from here all the way down here, right, let's go and give it another color. So make this one squiggle. Oh, that's probably will be, in this case, yeah, a little longer. That didn't draw it well. But you get the idea, right, is that it's going to be a different color and it's going to have its own different properties. So it's also going to have its own color as a result. So let's go back to the question at hand here. Again, where exactly does all this light come from? It comes from the relaxation of electrons after it's been absorbed from another place, right? So energy goes in, and then as a result of it being relaxed, it's going to release energy in the form of light. And different lights correspond to different energies. So I'm going to go back up real quick to this diagram here. So remember all these individual lines here, these colors, right? Those actually come from very specific patterns of relaxing. So this one, for example, might come from this first one right here going down, right? And then maybe back up here, this line might correspond to this relaxation, giving off this color, right? Again, the actual colors aren't really corresponding between the two diagrams, but you get the idea. Some colors correspond to some relaxation, and that color that comes out combined gives us whatever we can see with the naked eye. Finally, just an idea here. Remember, this example that I just showed you hydrogen with one atom, right? Excuse me, one electron. That one electron has, it can go up, it can go down, but it has its own patterns of going up and down. What if you had an atom with a lot more electrons, right? Well, that's again showing you that there's a lot more combinations of excitations and relaxations. But the important thing to recognize is that each one will give its own unique set of spectrum. Right? So these are all individual colors, or excuse me, these are all examples of hydrogen, helium, neon, sodium, mercury. These are the atomic emission spectra of each of these elements, and notice how they're all unique, right? They might have some similarities in the colors that are present, but their own unique set of colors are going to be represented here. And this, again, is not something you can see with the naked eye, right? I can't see Mercury's purple and blue and teal and green and yellow and red, right? We can only see them after they've been passed through a device that allows us to see that light split up. And of course, each of these colors, right, this purple right here, this blue right here, each of these correspond to a very specific pattern of an electron being relaxed from a higher energy state down to a lower energy level. So that's effectively, again, how we all put it together. Where does color, where does light come from? It comes from very specific patterns of electrons relaxing. All right, that'll do it.